All right, so guys, we are doing 5.7 day 2. This is our last lesson of chapter 5. And a couple of notes up here. Make sure you can check your answer to number 45 up on that sheet, okay? All right, your notes are gonna look a little different than mine. I slightly adjusted it. So yeah, let me know if you're like missing a problem, but I think I mostly just took out problems to give us more time to practice, okay? All right, so I'm gonna do things a little bit differently. We're gonna go backwards on the notes today. All right, we're gonna go backwards. So flip to the back. And I believe you guys have a word problem and I took it out. All right, so we're not gonna do that word problem. Instead, cross it out. And in the blank space on the bottom, I'm going to hit kind of like the main things for the lesson to start with. And then we're gonna use the examples to practice, okay? So I'm gonna draw, let's say a line here, pretend that's where your word problem is. All right, and a couple notes. All right, key concepts. All right, so key concepts for our lessons. All right, now one of the key concepts we kind of already talked about is when x is equal to some number, I'll just call it a, all right, so any number a, all right, if that is considered, that a is considered a 0 or a root, that means that x minus a is a factor of the polynomial, okay? So if x is equal to, let me do an example here. For example, if x is equal to 5 is considered a 0 or a root of a polynomial, that means x minus 5 must be a factor of that same polynomial. All right. Or if x is equal to -3 is considered a 0 or a root, that means x minus -3, which is x plus 3, must be considered a factor. Okay, so I'm just gonna call on some people and just make sure that's making sense. Okay, so try it out, and if you get it wrong, that's okay. Okay, that's why we're here, right? We're here to practice and learn. Okay, so let's try it. Let's do Ethan. Ethan, pick a number, any number.
1.
1, okay. If x is 1 is a 0 or a factor, or a root, what would be a factor?
X minus 1.
Yeah, perfect. Okay, exactly. All right, let me go the other way. If x minus 4 is a factor, x is equal to what must be a 0 or a root? Michael, why?
I'm sorry, could you repeat that? X minus.
If x minus 4 is a factor, x is equal to what?
The root would be 4.
Would be 4, exactly. Nice. Okay, let me do one more, and I'm gonna see if I can be a little more difficult. If x is equal to, or let's go the other way. If x plus 9 is a factor, then what must be a root? Bowen. Bowen, what must be a 0 or a root if x plus 9 is a factor?
-9.
-9, perfect. Good job. Okay, so hopefully you guys are understanding that. So that is one of the main concepts that we're going to be using today. Okay. All right. Another concept we're going to be talking about is what's called the conjugate. I think I have it actually up here at the very top of the notes. Yep, the complex conjugate theorem is its official name. All right, but let me go ahead and show examples down here for a little more room. So the complex conjugate theorem, okay, conjugates are when you have basically the exact same binomial, right? You have two terms here, where one is a plus sign in the middle and the other is a minus sign in the middle. But other than that, all the rest is the same. The only difference is one's a plus and one's a minus. So for example, if I have, let's say 2 plus 3i, its conjugate would be 2 minus 3i. Okay. Or if I have negative 5 plus 4i, then the conjugate would be negative 5 minus 4i. Right? Only that middle sign changes. Or if I have negative 8 minus 7i, then the conjugate would be negative 8 plus 7i. All right, so those would be considered conjugates, okay? All right, so let's have you guys practice. I'm gonna call in people, and again, give it your best shot, and let's see what we got. Let's say if I got 1 plus 5i, what would be its conjugate, Timothy?
1 minus 5i.
Perfect. Nicely done, Timothy. All right. What if I have, let's do 4 minus 2i. What would be its conjugate? Rachel.
4 plus 2i.
Perfect. Nice. Okay, let's do one more. Let's do negative 6 plus, I don't know, 5i. Negative 6 plus 5i. Brendan would be the conjugate. Go for it.
All right, would it be negative 6 minus 5i?
Perfect. You got it.
Oh, I'm so smart.
Smart.
Woo.
I know, right? Crazy.
Right?
Crazy how smart you are. All right. So I think you guys got it. Conjugates. Okay. So now let's show you how to use those conjugates. Now you know how to make those conjugates. All right. So this is how we're going to use it. Like I said, we're going backwards today. All right. So number 5, write a polynomial function of least degree with integral coefficients. Integral coefficients just means like no fractions, no decimals. You guys don't want to deal with those anyway, so that's a good thing. That has the given zeros, all right? Zeros, AKA roots, same thing. Okay, so number 5. I know that x is equal to negative 1 is a root, right? It's a root, it's a 0. Which means what is a factor then? Celine. If negative 1 is a root or a 0, what would be a factor of this polynomial?
It would be x plus 1.
Perfect. Good. That is a factor. Okay. So we got this one. All right. Now, 4. If 4 is a root or a 0. All right, I'm not going to write this every single time. Okay, so I'm going to simplify this down so you guys don't have to write as much. Okay, so this means x plus 1 is a factor. Okay, Riley, if 4 is a root or a 0, what is a factor?
X minus 4.
Perfect. Okay, good. Done. We have those two. Now, watch carefully, guys. Here, you got an imaginary number. Now, the conjugate theorem, what it tells us is if I know I have a complex number is a 0, its conjugate is automatically also a 0. Okay? So I didn't show an example like this one, but if 3i, right, is our term, what is its conjugate? Does anybody have a guess on what the conjugate of 3i would be? Yeah.
Negative 3i.
Yes, good job, Timothy. You got it. Negative 3i. If you're not quite sure, like, wait a second, why is that? Think about 3i as 0 plus 3i. All right, think about a 0 plus 3i. So that means 0 minus 3i is its conjugate. All right, good. So that means 3i is a root and its conjugate, negative 3i, it's like the hidden secret root also, right? So anytime you guys see imaginary numbers, you have that hidden secret conjugate also must be a root. Okay, good. Now this might be a little trippy, but I think you guys can handle it. If 3i is a root, what must be a factor? Anyone? Anybody want to try it? If 3i is a root, what must be a factor? No? Too scary? Okay, no worries. I'll show you. It's the same thing as what we did before. When 4 was a root, x minus 4 is a factor. So if 3i is a root, x minus 3i must be a factor. Okay, so don't let the I scare you. It's the same thing.
Real quick, Mrs. Leong.
Yeah, what's up, Maddie?
My cat just pooped on my floor. Can I go clean it up, please?
Yes, please. Go.
Okay, cool. Sorry. Thank you.
No worries. All right. The joys of distance learning. That would have never happened in a classroom. Okay. Now, our negative 3i, right, is a root. So does anyone want to try this one? What must be a factor?
X plus 3i.
Good, Michael. Yes, x plus 3i. You got it. You got it. All right. So these are all the factors of this polynomial function. Now, all we have to do is multiply a bunch. Okay, we got to FOIL, FOIL, FOIL. All right, so I'm going to do this part real quick for you guys. I'm going to FOIL those because I know you guys can FOIL. And this would FOIL out to be this. All right. Now, these two, I would definitely multiply those two. All right, and I'll do this one a little bit slower. So x minus 3i times x plus 3i, let's FOIL. And I get x times x, which is x squared. X times 3i gets me 3ix. Minus 3i times x gets me minus 3ix. And this last one, negative 3i times positive 3i, gets me negative 9i squared. Now, if you did your conjugates correctly, these terms should cancel out, right? That gets to 0. And if you guys remember, I square is -1. So replace I square with -1, and we get x squared plus 9. All right, and now we just need to multiply this with this to get our final answer. So let's go ahead and FOIL this out. I got x squared plus 9 times x squared minus 3x minus 4. Let's multiply. And I get x to the 4th minus 3x cubed minus 4x squared. And then multiply the 9. I'm going to stack them so I can combine my like terms easier. So positive 9x squared, negative 27x, and then plus 36. Let's add those up and I get x squared, x to the 4th minus 3x cubed plus 5x squared minus 27x plus 36. All right, and that should be our polynomial. Okay, questions, and I can do a f of x, or you can do a y is equal to if you want for your final answer. Okay, let me take a pause. Any questions? All right, so for number 6, I'm gonna have you guys help me out more and see if you got it. Okay. All right, I have a root of 2. So what should be its factor? Angie, what do you think?
-2.
You need an x. So print.
X minus 2.
Good, nice, Angie. You got it. You got it. All right, next one, the 5. Gloria, what factor?
X minus 5.
Good. Okay. Now, this next one, ooh, I have an I. So if I have an I need to make sure I have the conjugate. So I have 1 plus I, which means its conjugate must be a factor. Let's go to Michael P. What would be 1 plus I's conjugate?
Would it be -1 minus I?
Ooh, close. Keep the number at the front the same. Only change.
So this 1 minus I.
Perfect. There you go. So 1 minus I. 1 minus I. Good. Okay. Now I'm going to take over from here because it gets a little trippy. Okay. This guy, you're like, oh, shoot, I have 2 terms. It's okay. Same thing that we did with the 2 and the 5, we're going to do with this one. So now this factor is going to be x minus 1 plus I. Right? So it's the same thing, x minus whatever that root is. And this guy will have x minus the 1 minus I. Everybody okay? I know it looks weird, but it's just x minus whatever the root is. Okay. All right. And then now we just need to FOIL and multiply. All right. This one's going to give me x squared minus 7x plus 10 for this one. And this one, you just have to be super careful, guys, when you multiply the ones in blue. Okay. This one, let's simplify. This is going to be x minus 1 minus I. And this next one will be x minus 1 plus I. All right, when you simplify those parentheses on the inside. Now let's FOIL, or I guess distribute, multiply, whatever you want to call it. All right, so this gets me x squared minus x plus ix. Multiply the negative 1. So I have negative 1x plus 1. All right, I'm going to put that on the side since I'm trying to combine anything similar, and I don't have anything similar. Up top, minus I. All right. And then negative ix plus I minus I squared. All right, and let's see what we get. We got x squared minus 2x. These cancel out. Ix minus ix. These cancel out. And I'm left with plus 1 minus I squared. Now the I squared, remember guys, you can replace that with a negative 1. So that leaves me with negative 2x plus 1, so that's plus 2. Okay. All right, and now we just need to multiply this guy with this guy. Okay, so lots and lots and lots and lots and lots of multiplying. All right, so then we have different color here. X squared minus 7x plus 10 times x squared minus 2x plus 2. Ooh, here's a hint, guys. For these, notice it all comes out like really nicely. Like there's no I's in there. If you're doing it right, all your I's should actually, cancel out like you saw up there. All right. So if you're not getting that, you should double check, go back and see if you made any careless mistakes. Because your answers should come out very nicely. All right, and distribute, distribute, distribute. We got negative 7x cubed plus 14x squared minus 14x. And then lastly, plus 10x squared minus 20x plus 20. And let's add those all up. All right, we got y is equal to now x to the 4th minus 9x cubed plus 26x squared minus 34x plus 20. Make sure I'm making careless mistakes. Whew. Yes. That is it. Ooh, that's a beast. All right. That is how it's done. Okay, let me take a pause. Questions, concerns, let it marinate. Let it marinate. Ask any questions if anything's not making sense. All right, flipping to the front, guys, let's go ahead and finish this off with our main event, which is to find the zeros of functions. All right, that's what we've been doing for like the past however many lessons. So let's try some of these. All right, so number 1, find all zeros of each function. You guys will definitely get problems like this on the quiz, for sure, where it just says find the zeros, okay? Now, this is what you guys want to do step by step, okay? First step is just see if you can factor it, okay? If you can factor it, it makes it so much easier. So looking at this, I can see I can factor this by grouping. If I take out the x squared, I'm left with x plus 1. If I take out the 9, I'm left with x plus 1. So I can factor this and I get x plus 1 as my twins, and I'm left with x squared plus 9. All right, and I want to find the zeros from these factors. So here, this will get me x is equal to -1. Here, I get x squared plus 9 is equal to 0. X squared is equal to -9. Square root, and don't forget that plus or minus. All right, so x is equal to plus or minus 3. And because of the negative on the inside, I got to pull out the I. All right, so those are my answers. Okay, so if you can factor, do it. Now the problem is not all of them are factorable. So let's try and see what happens if I can't factor. So number 3. All right, so looking at that, if I did the same thing I did with number 1, I wouldn't get twins, right? If I pulled out the GCF, I wouldn't get twins. So that's why it's not factorable. So for number 3, I need to use the strategies we've been kind of doing for the past few days. Starting with, let's get a list of all possible rational factors. Let's get the P and Q lists. Okay. So since Q is just 1, right? The factors are just 1. I can just go ahead and do the factors of 40. All right, so I can do plus or minus 1, 2, 4, 5, 8, 10, 20, and 40. I think those are all of them. Okay, so this is kind of like my starting list of what could potentially be some of these zeros I'm looking for. All right, now my next strategy that I'm going to use is, well, this is a long list. I don't want to test every single one of those. That seems like it's going to take a lot of time. So let's figure out, well, how many positives and negatives are there? Because that's going to help me kind of narrow down what I want to test out. So using what we learned yesterday with Descartes, I see I have a positive term, a negative term, a positive term, and a negative term. So I have 1, 2, 3 sign changes. All right, so with 3 sign changes, that means I have 3 or 1 positive roots. All right, so that's good to know. Now let's go ahead and plug in when A is negative. If I plug in negative A, I'm going to get a negative term here. I'm going to get another negative term, another negative term, and the negative 40 is still negative 40. So this tells me I have no sign changes. I'm going to have 0 negative rational roots. That's huge. Knowing that eliminates half of my list in this P over Q list, right? I don't have to test any of the negative ones because I know I'm not going to have any negative ones. All right, so let's start testing now that I know that. So big L, and let's try it out. All right, so I got my coefficients from the original problem. I got 1, -10, 34, and -40. Let's try +1, see what happens. Drop it down, multiply, add, multiply, add. Yes. All right, multiply and, ooh, this is not 0. No good. All right, let's try again. Let's try +2. 1, multiply, -8, multiply, add that, I get 28. And, ooh, not quite. But getting a little closer, right? If you look at the remainder, this one would have been negative 15. This would have been positive 4. So I'm getting closer to getting at 0 remainder. All right, so that's promising. Let's try 4. 1, negative 10, 34, negative 40. Drop it down, multiply, add, multiply, add. Yes, we got the 0 remainder. All right, so that means 4 is a 0. Awesome, and not only that, I have my depressed polynomial here, which looks like I might build a factor. Let's see. No, I actually can't factor. All right, let's use quadratic formula then. So x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. All right, and I get negative 4i, oops, negative 4, oops, sorry. No I yet, didn't take it out of the root yet. And that gets me 6 plus or minus 2i over 2, which is 3 plus or minus I. Okay, so those are my answers. X is 4 and 3 plus or minus I. And I have 3 answers. And I look at my degree, just double check, and yes, my degree is 3, so I should expect 3 answers, which I did get. All right, guys, and that is everything. All right, with all of our theorems put together, Descartes in there, rational root theorem, synthetic, quadratic formula, imaginary numbers. Oh my goodness. You guys, all this goodness in there. All right. Questions. I think it'll take practice, but any
Did
questions?
you mean Descartes?
Yes, I meant Descartes. Thank you. All right. Cool. You know what? It just takes practice, guys. So I'm going to have you practice 2 and 4. All right, 2 and 4. I'm going to call on people. So get yourself ready. Let's jump to number 4 and we'll see how far we can get. All right. Start with number 4. We'll see how far we get. All right. So get ready. Calling on people. Number 4. Okay. Russell, I'm going to start with you. All right. So Russell, what do you think? What would you do first if you're trying to find the zeros of this polynomial?
See if we can factor it.
Yes, good job. Check to see if you can factor it. Russell, what do you think? Can we factor it?
I don't think so.
No, we can't. Yeah, when we try to pair it up and try to pull out, numbers, we don't get twins when we do that. Like number 1, we got twins with the x plus 1 and the x plus 1. Not going to happen in this case. Okay, so Russell, what do we do instead now knowing we cannot factor?
We do p over q.
Nice. Okay. So p over q, what are the factors of 15?
So it would be plus minus 3,
Mm-hmm.
plus minus 5,
Mm-hmm.
and then plus minus 1 and plus minus 15.
Good. And then what are the factors of q?
Oh, 1.
Is 1. Okay. So your final list would be basically what you said, right?
Yeah.
Okay, cool. I think you were going for that final list. Sorry, I wasn't there yet. Okay, perfect. Looks good. Thank you, Russell. Let's move on to Gloria. All right, Gloria, what can we do next?
I think you make it into the equation.
Okay, so what do you mean by that?
I'm sorry, I think I forgot.
Oh, it's okay. No worries. Let's use Descartes, like Descartes' rule to kind of tell us, well, how many positives, how many negatives can we expect? Kind of like the blue on number 3. Let's look at how many sign changes there are. Okay, so looking at number 4, is the first term positive or negative?
Positive.
Good. All right. Is the second term positive or negative?
Negative.
Good. Keep going.
Positive and negative.
Good. So how many sign changes do you see?
3 sign changes.
Good. Nice, Gloria. So if there are 3 sign changes, that means I can have how many possible positive roots?
Is it 3 or 0?
Ooh, close. 3 or go down by 2. Like 3 minus 2 gives you 1. There you go.
1.
Yes. All right. So 3 or 1 positive. Okay. Gloria, what about the negatives though? How do I find the negatives? How many negative roots? What do I do to find out?
You plug in negative x.
Good. Yes. Okay. So when I plug in negative x, is the first term going to be positive or negative?
Negative.
Perfect. Good. When I plug in negative x, is the second term positive or negative?
Negative.
Good. Third term.
Negative.
Good. And the last term.
Hello. Positive.
There's no x. So negative 50
Oh, so
is just
negative.
negative. Yeah. So how many sign changes do you see here, Gloria?
0 sign.
Zero.
0 sign changes.
Yeah. That means I have 0 negative roots. So automatically, I'm not going to test any negative numbers in this list because I know I don't have any negative roots. Good job, Gloria. Nice. Okay. Let's go to Jackson. Jackson, what do I do from here?
Do we put it in the equation now?
Yes. Okay. So tell me what to write.
I don't know.
So
I just know we.
use the coefficients from this top part. So what's the coefficient of x cubed? Like what's the number in front of x cubed?
1.
Okay, good. Now what's the number in front of x squared?
5.
With a
1. -5 and then 11 and then -15.
Perfect, you got it. Okay. Now Jackson, you get to choose now. From this list, we only want to test the positive one, so pick one of those positive numbers to try.
1.
Cool. All right, let's try 1. Let's do synthetic division. Okay, so Jackson, help me do synthetic division on the 1.
Okay, first one, you bring it down as just 1. And the second one, -5, right?
What do I do? Well, what do I do with this 1 that you dropped down?
Multiply it by -5.
Multiply it with the 1 on the outside.
Multiply it by 1, so you get 1. And then you do -5 minus or plus the 1, so just -4.
Perfect.
And then you do the -4 times 1. And then you get 11 plus -4.
Good. And that gets you 7? 7?
7, yeah, sorry, my audio cut out.
Okay, no worries. Yeah, 7. Okay, and then?
And then 7 times 1.
Okay.
And then you get -8.
Okay, so does that make us happy?
No,
No, it doesn't, because what do we want that remainder to be?
0.
0. Okay, so no good. 1 is not a root. Okay, so what should you do next?
Use a different number.
Okay, so pick a different number.
Let's just go 5.
Let's do 3.
3.
All right. And actually, Jackson, I'm going to take over because we are low on time.
Okay.
I'm going to rush through this. And ta-da! We got one. All right. I was hoping you would pick 3, but you like decided to jump it.
I was going to, but then I thought it probably wasn't. So
Yeah, isn't that always the case where you're like, oh, it's probably not. And then of course it is.
yeah.
Yeah. And then just do quadratic formula. Again, if you can't factor it, minus 4ac all over 2a. All right, so got 2 plus or minus is going to be rad negative 16 over 2, which is going to be 2 plus or minus 4i over 2. And so this gets you 1 plus or minus 2i. All right, and that's our final answer. 3, 1 plus or minus 2i. Good job, Jackson. Nicely done. All right, sorry I rushed at the end, guys, but hopefully you were following along. If you have any questions, stick around. If not, you guys are good.